Hi everyone, I'm Irene Van Worden. I'm an assistant professor in the Department of Community and Public Health. In this video, I'm going to go over and show you Jamovi, which is the most user-friendly, intuitive statistical software package that I have seen so far. Jamovi is built on the statistical language of R, which means that while it's a new software, it's built on some really good programming language. And the really nice thing is that as well as being super intuitive, super easy to use, it's also free and open, which means it's a free download. So to download Jamovi, we go to jamovi.org, this website here, and then click on download. Now, I'm using a Windows computer, and so Windows has come up automatically for me. This solid version is what I would recommend for pretty much everybody. So these numbers might change, that's just getting newer versions, but you want to be clicking on the solid versions. Now, some Mac users in particular may find that the solid version doesn't work for them perfectly. It has some download errors that may have been changed since I had my students downloading it. And if that's the case, click on the current version. It's going to have some more different features. It's a little bit more of a test version, but so far that really hasn't been a problem. When you go and install Jamovi, you're going to click on this little V here for Jamovi. And this is what it's going to look like. So the first thing that we're going to do is bring in our data. So we have an analysis tab where we're going to do all of our analyses. We have a data tab where we can edit our data. And to the left of this, these three horizontal lines is where we can bring in our data. So we're going to go to open. We're going to go to browse, and we're going to navigate to where our data is. Since I already have opened my data set before, I'm going to go down to recent and click +1 blood pressure data set, the data set that I'm going to be using for this demonstration. So you can see now that my data has been pulled in and I can see it all here. Note that I have not dummy coded my variables. So I've got my age, I've got 75-79 for my age group of 75 to 79-year-olds. That's not a problem. For my BMI status, I have overweight, obese, normal weight, and I've got underweight. These text columns are absolutely fine. And that's one of the really main advantages I see in Jamovi, is that rather than having everything coded to 0, 1, I can code it to my text field directly. Now we have a setup column. So Jamovi is going to automatically guess what variable type you have. So BMI has gone through as a nominal variable. I'm going to change that to ordinal, and then I'm going to change my level. So I want my underweight to be my first level. So using my arrows on the right, I'm going to change these. So underweight, normal weight, overweight, and then obese makes the most sense for this variable. And I can go through my other variables as well and change the levels as I want to. So does someone have balance problems? I'm going to set that to an ordinal variable, starting off with never, sometimes, regularly, always. Changing these levels here is going to mean that my tables that use this variable are going to show up with the levels in this order. Now I can scroll through and see my other variables. So for instance, here I have diastolic blood pressure at baseline. That's come through as a nominal variable, and it really should be a continuous variable, as should after 1 minute, and diastolic blood pressure after 3 minutes. And I can also compute and transform my variables if I wanted to, and add in a filter. So if I wanted to only look at the males, I could say equals sex, so that's my variable name here, sex, S-E-X in capitals, equals male. Now you can see that I have my first filter, and all of the places where the sex was not male have been crossed out. If I run my analyses with this filter, I'm only going to be running my analyses for males. And you can add multiple filters as well. Going into the analyses, the first step we want to look at is our exploratory data, our descriptive statistics. So let's say we want to have a summary of our first continuous variables, our age, our height, and our weight. It's going to come up automatically on the right-hand side of the screen. And we can choose what statistic we want to see. So I want to know the standard deviation. I don't want the minimum or the maximum. I don't want the median, but I do want to check the subnormality. And you can see it's automatically coming up on the right-hand side of the screen as I click. We can also split by a variable. So say we're interested in age, height, and weight between males and females. I can click on sex and bring it through to my split by variable. And now I'm getting all of the same information as before, but for my males and my females separately. We can also have a look at our plots. So histograms, box plots, bar plots, everything. And they're going to come in again automatically on the right-hand side of the screen. I'm just going to unclick height and weight because we don't need to see the same plot over and over again. So this is the distribution of age, just the plot. So you can see it's being split out by sex because I have the split by sex. If I remove the split by sex, then the plots are just going to show age distribution by itself. I can also look at categorical variables, for instance, BMI. And if I go into my frequency tables, it's going to show how many people were in each of these different levels of BMI, a BMI force, my weight status, what percentage that was, and my cumulative total. And it's also going to show me my plots. So this is my distribution of how many people were at each of these 4 different weight statuses based on your BMI. There's actually an even nicer method of plotting. If you go to modules on the right-hand side and go to Jamovi library, roughly halfway down, you're going to find FlexPlot. So FlexPlot, graphically based data analysis. So I have already installed it, but so you're going to want to click on this install button, and then it will automatically come up, and you're going to have this icon here. When you click FlexPlot, then click on FlexPlot again, you can bring across your variables. So say we're really interested in BMI and age. They say BMI is the outcome variable. The FlexPlot is automatically going to give you the histogram because it thinks that's the most sensible plot to show you if you just want to look at BMI. If you're interested in how age predicts BMI, then it's going to automatically change to this type of plot. And say you're interested in the difference between males and females, you can use that as a paneling variable and then get the plot for males and females. We can also look at categorical variables, such as I can bring across balance problems as my outcome variable, and just get the distribution of balance problems. After we've explored our data and have a good understanding of what our data looks like, the next thing we're likely to want to do is look at some bivariate tests, say our chi-square test, our t-tests. So our t-tests, as you might expect, are under the t-test button, nice and intuitive. We have our one sample t-test, our paired samples t-test, and our independent samples t-test. So if we look at our one sample t-test, let's say we're interested in if BMI, the mean of BMI could be 25 or not. The first thing I want to do is check my assumptions. So I have my Shapiro-Wilk test and my QQ plots coming in here. If my data did not meet my normality assumptions for my student's t-test, I could click on my Wilcoxon rank test instead, and my statistics are going to come through. So I can see when I click on Wilcoxon rank, I have a Wilcoxon W coming through here and my p-value. I can also change my hypotheses to whether it doesn't equal the test value or is greater or smaller than the test value. The automatic output gives you the statistics, degrees of freedom, and the p-value. You can include the mean difference and the confidence interval, and these additional statistics here if you want. So here I've clicked on descriptives, the mean difference and confidence interval. So I can see that my mean BMI was 25.27 with a standard error of 0.31. So I'm really not expecting there to be a difference in this BMI to a mean of 25. I can see my p-value is 0.379. The mean difference is 0.27, so 25.27 minus 25 is 0.27. And my 95% confidence interval is here. If I wanted to use, say, a 99% confidence interval, I could just change this number and this would change up here. I also have my independent samples t-test. So if I want to know if there's a difference in BMI by sex, I'm going to put BMI as my dependent variable, my grouping variable is sex. I'm going to check my assumptions and then use either my student's test, my Welsh test, or my Mann-Whitney U test as appropriate. So you can see they're all coming through on my right-hand side here. Again, I can change my hypotheses to not equal or greater or less than, and I can bring through additional information such as my mean difference and my 95% confidence interval. If I bring in my descriptors and my descriptors plot, if I go down, I can visually see how BMI looks like for my grouping variable of sex. I also have my paired samples t-test. So for instance, if I'm interested in whether there's a difference in systolic blood pressure at baseline and after 1 minute, I'm going to click both of them and bring them across as paired variables. Again, I can check my assumptions and then click either the student's or the Wilcoxon rank test as appropriate. I've got my hypotheses of not equal, greater than, or less than, and I can bring through my additional statistics such as my mean difference and my confidence intervals. We also have our ANOVA tests. So ANOVA, repeated measures, ANCOVA, MANCOVA, and our non-parametric versions as well. So I haven't needed to use the one-way ANOVA yet. I've simply used this ANOVA here. So let's say we're interested in if there's a difference in BMI by civil status. We can look at our assumptions, and then these assumptions look fine. We can see there's a p-value of 0.486. So I really wouldn't want to be looking at the post hoc tests for this p-value, but I'm going to do so just for the example. So I'm going to go down to post hoc tests and click civil status. If I scroll down here, I can now see the difference between all of these different pairs of my civil status. I can also have a visualization of how BMI is changing by going to my estimated marginal mean. So I can have my plot. I can also bring through a table if I wanted to. And this is showing me the mean BMI by each of my civil statuses here. For repeated measures ANOVA, let's say I'm interested in systolic blood pressure, baseline, after 1 minute, and after 3 minutes. So I'm going to type in what I'm interested in and my different labels in here, and then bring through the variables into my repeated measures cells. I'm going to make sure that my baseline variable matches to my baseline text and say after 1 minute and after 3 minutes. This here is showing me that there's a significant difference, but I haven't checked my assumptions yet. So I'm going to go to my assumption tests and check my sphericity. So I'm going to ignore this outcome and just pretend that my sphericity is fine. I'm going to go to my post hoc tests and bring through systolic blood pressure as a post hoc to see where the differences are. So I can see it is a significant difference between baseline and 1 minute. I've got my P2P of less than 0.001. Same as this difference between baseline and 3 minutes and between 1 minute and 3 minutes. I can get a visualization for that by going to my estimated marginal means box. And there I can have my plot, which is going to come up. And I can also bring through a table. So everything you click on the left-hand side is going to show up on your right-hand side. So here I can see there are significant differences between all of these three, what the means actually are, my standard errors, and my confidence intervals. I have ANCOVA and MANCOVA as well, which are really similar in format. For my non-parametric tests, I have my one-way ANOVA with my Kruskal-Wallis. So let's say I'm interested in BMI, and I'm just going to pretend that civil status is no longer meeting my parametric assumptions. So I'm going to put civil status as my grouping variable, but I can see my p-value is 0.643. So again, there's really no need to look at my pairwise comparisons. I'm going to be doing so just for the example. So you can see the p-values for each pairwise comparison is coming in here. And I also have my effect size. I have my repeated measures ANOVA as well for my non-parametric version. So let's say I'm interested in systolic baseline after 1 minute and after 3 minutes. I'm going to bring that through on the right. I can see it's a significant value. So I can bring through my pairwise comparisons, my descriptives, and even my descriptive plot. And I can see what my p-values are. So pairwise comparison says they're all significantly different. I have my descriptives, and I can see what the means are showing for my descriptives. So I can see that there's a significant difference between all three of these. I'm going to skip over regression for now and go to frequencies. This is where we're going to have our chi-square test. So in our contingency tables, our independent samples chi-square test of association. So if we're interested in our categorical variables, let's say we're interested in our BMI-4, so our 4 different levels of weight status. And let's say we're interested in stacks in our columns. This is what our chi-square table looks like. So I've actually got a 4 and a 1 for male and female. So if I was doing this, I'd probably want to group underweight and normal weight together. The statistics we can bring through are our chi-square test, our chi-square continuity correction, and our Fisher's exact test. So for now, our chi-square test is fine. We can also bring through confidence intervals if we wanted to. Now for ourselves, I want to have my column percentages so I can really compare what my percentages are doing. I can bring that through into a manuscript or into a thesis dissertation. Let's say I want to have a look at falls and sex. So now I have a 2 by 2 table. So I'm going to click on my chi-square continuity correction p-value instead. And if I wanted to, I can bring through my odds ratio or other values like that, and also get my confidence interval for that. Going into a regression. So I have my linear regression in here, as well as my logistic regression underneath. So clicking on linear regression. So let's say I want to predict BMI, so BMI dependent variable, by age. So I'm putting age in here because it has a rule, and I have sex down here because it's not a continuous variable. Now I have my R and my R squared and my model coming up automatically. And I can go down, I can have a look. So if I wanted to, I could change the order of these variables. I could also change and do it plotwise. One thing I really like about Jamovi is you can really easily change the reference level. So right now, female is the reference level. Now the model's going to update, so male is the reference level. I can go through and check all of my assumptions just by clicking on all the different buttons and then looking at the readout on the right-hand side. I can bring through additional model fit variables here, such as my adjusted R squared. I can have a look at my estimates and my marginal means. So let's say I want my 95% confidence interval for my model coefficients. If I go up, now I have my 95% confidence interval for these terms. Regarding logistic regression, I'm going to click on binomial. Let's say I'm interested in predicting whether or not someone is overweight by their age and their sex, whether or not they've had a fall. And let's throw in alcohol and smoking as well. When we go to our reference levels, I might be want these to have yes as the reference level. I can do this very easily just by changing the level here. I can check my collinearity, check my variance and inflation factors, my VIF, have a look at my model fit, bring through I like my confidence intervals. So I'm going to bring through my confidence intervals for my log odds, my odds ratio,